Welcome to qnawire.
Okay, our question says that three vectors are shown in figure 38. Their magnitudes are given in arbitrary units. Determine the sum of the three vectors, give the results in terms of A, the components, and B, magnitude and angle with x-axis. Okay, so first, you'll notice that I drew out the figure 38. I labeled the coordinate system, the xy coordinate system, in black. The vectors A, B, and C I drew in red, okay? And then the angles that vectors A and vector B makes with the x-axis, I drew as theta A and theta B in green, okay? And this is what we're given. We're given the magnitude of A is equal to 44. The magnitude of B is equal to 26.5. And the magnitude of C is equal to 31. And then theta A is equal to 28 degrees, and theta B is equal to 56 degrees. And the question is, what is the sum of all these, A plus B plus C, for A, in terms of A, the components, which are the x hat and y hat components, or the x and y direction, and then B, in terms of the magnitude of the sum, and the angle that sum makes with the x-axis. So we will indicate that as that theta sub x, for the angle that it makes with the x-axis. Okay, so first we need to determine what the components are in the x direction and the y direction. So I'll write that as the component in the x direction, I'll write as a sub x, and that's going to be equal to the magnitude of A, right, multiplied by the cosine, since it's in the x direction, is multiplied by the cosine of the angle, which is theta A. Okay, and this comes out to be, if you do, magnitude of A is 44. If you multiply 44 times the cosine of 28 degrees, you get 38.85. Okay, so we know what AX is. Now, we want to figure out AY. Okay, well, AY is going to also be the magnitude of A, but this time it's multiplied by the sine, since it's in the y direction, by the sine of theta A. So now we have 44 multiplied by the sine of 28 degrees, and this comes out to be 20.66. Okay. Now we want to go ahead and carry out these exact same actions for bx and by. Bx, we have magnitude of b times the cosine, it's magnitude, times the cosine of theta b. So magnitude of b is 26.5. You multiply 26.5 times the cosine of 56, and that comes out to be minus 14.82. And if you ever wanted to do a mental check, just a sanity check, we can go ahead and compare what we're getting back to the graph. So if you look at the graph, A is clearly in the positive x and the positive y direction, and we get values in the positive x and the positive y direction. And then B is clearly in the negative x direction, and we just got a value in the negative x direction, so that seems to be correct, but it's also in the positive y direction. So we'll see if for B sub y, we get something in the positive y direction. Okay, so I forgot my magnitudes on this for this A. So now we want the magnitude of B multiplied by, since we're dealing with y, the sine of theta B. This comes out to be 21.97. Indeed, it is in the positive y direction as expected. Okay, and lastly, we need to do this for c sub x and c sub y. So we want to find c in the x direction. Okay, so that's the magnitude of c times the cosine of theta c. Well, theta c is clearly, well, you really don't even need to do this calculation. If you look at the graph here, you'll notice that there is no x component to C. C is along the y axis line, so there's no x component to C. So this one actually has to be equal to 0, right? And even though it's not given explicitly, we can go ahead and determine, if we want to write this up top, that's fine. Theta C is equal to 270 degrees. And we know that because, well, one, if we start 0 degrees is along the positive x axis, then 90 degrees is the positive y axis, 180 degrees is the negative x axis. You keep going. 270 degrees is the minus y axis, and then 360 degrees is also the plus x axis. So it gets the full 360. So C sub x is going to be equal to 0. And then C sub y, well, we can just use the same trick that we just used previously. Well, since it's all in the y direction, we know that that C sub y is just going to be equal to minus, because it's all in the minus y direction, minus the magnitude of C. So that's going to be equal to minus 31. Okay, so now we've determined all of the components in the x and y direction for A, B, and C. So we can go ahead and move on to part A, which asks us to calculate those components in both the sum of those components in both the x and the y direction. We're going to go ahead and do that on this next tab here, and we'll denote this as part A here. Okay, and let's add A. First, let's do the x direction, plus B plus C in the x direction. These are all x. So we're going to be adding all the x components together. This is 38.5 for A, or I'm sorry, 38.85 for A. Right? Plus, for B, it's minus 14.2. So this is plus minus 14.2. I'm sorry, 14.82. 14.82. Okay. And then we're going to add to that 0 from C. There's a 0 in the x direction from C. So if you go ahead and carry this out, you get 24.03. But we only have three significant figures that we can keep because of what we were given in the beginning. So this comes out to be 24. Box that in as our solution. Okay. And then we're going to do the exact same thing for the y direction. So it's A plus B plus C in the y direction. Okay. Well, A in the y direction is 20.66. Plus B in the y direction, which is 21.97. Plus C in the y direction, which was minus 31. Okay. Carry out this operation, and you get 11.6 for reporting to three significant figures. Okay. Now, for part B, let's go ahead and start part B right here since we have some room. For part B, it wants us to determine the magnitude in the direction of this sum. So we want the magnitude of A plus B plus C. Well, so that's going to be equal to the square root of the square of the two sides for the x component and the y component that make up the sum a plus b plus c. Okay, so that's going to be 24.0 squared. What's going on for the magnitude of the sum in the x direction, plus 11.6 squared I'll extend that square root for the magnitude of the sum in the y direction. Okay, well, if you go ahead and do that, you square those and you take the square root of that, you get 26.7 as the magnitude. Okay, now we want to find directionality. So we're going to to find directionality, we're going to use our trigonometric identity. Tangent of the angle that it's making with the x direction is equal to it's going to be the opposite over the adjacent. Well, the opposite in this case is 11.63, right? For what's going on or I'm sorry, 11.6 for what's going on in the y direction. And that's going to be divided by what's going on in the x direction, which is 24.0. Opposite over adjacent. Okay, well, theta is what we want, theta sub x. So we can solve for that. And that's going to be equal to the inverse tangent, which is written as tangent to the -1 of, again, the opposite over the adjacent. 11.6 divided by 24. Okay. And if you do that, this comes out to be 25.8 degrees. Box that in.